Hi, so in this lecture, we're going to go over some of the questions based on the standard normal distribution. That is from the normal distribution chapter 11. So here's the first question based on some birth weight, and we have been given a distribution of birth weights of children for late preterm babies with normal distribution. That's how you read. Okay, so this is normal distribution. You can make use of all those properties. With mean or mu, that's the first number before comma, and standard deviation for population, that's sigma after the comma in the parenthesis. So that's how you read this. And then this is the first question that's been asked: what is the probability that a randomly chosen late preterm baby would have birth weight, low birth weight less than 2500 grams? So this is nothing but your x value. So in this case we can say x1 because we have similar other problem, type B. uh, Whenever you have been asked to calculate area, so this is this type of question. X is known, so x is known to you and you have to find the corresponding area. And this is like the schema, like these are the steps that would help you follow or solve the problem in a systematic way so that there will be less error. First step is always draw the curve. Second, write all the given data or data values. What is mu, what is sigma, what is x, and we just probably might want to find the z. So if z is not given, calculate the z in the third step, and then from that z, find the area using z table. That's nothing but the table P. So from x, find the z, making use of this z formula, then make use of table outside in, from outside to inside, and find that corresponding area, percentile, proportion, probability, all same. So let's just draw that. So we are going to draw, I have already uh, made this normal distribution curve. So we just show that it's normal distribution curve with mean value being 2750. That's the mean given in here, 2750, and you can maybe write sigma somewhere here, 560. Also locate this particular x value, 2500. Now 2500 is going to be less than this, so draw it somewhere here, and this is now the key piece of information, less than 2500. So you are interested in birth weight less than 2500, so everything less than this particular number, so this red area, that is what you want to find. Next step, write down whatever given. So we have already written down in here mu, x, sigma, so we don't have to write it again. Now for z, we know it's x minus mu upon sigma. We know all these three values, x, mu, sigma. You just plug those in, find the z value. Make sure you also do not forget the negative value as well, um, because in table you can find positive and negative values. It's not going to make a lot of difference, but just to start with, just make sure you consider that negative value as well. Now, using this score of z negative 0.45 and making use of table outside in, how should we find this area? So let's go to the table. So this is the table, and let me rub this part. So we already have orientation to this table, that these kinds of z table gives us area left to this z, corresponding z, whatever we are looking for, and then we know that we need to look into this z scores as fine coarse adjustment, and then addition of fine adjustment to that coarse adjustment to get that specific number. So our z was by calculation, negative 0.45. So locate that along this first column. Negative 0.45 will be go all the way till you hit negative 0.45, negative zero point 0.4. Okay, we have negative 0.4 and we have negative zero point 0.5. We don't have negative 0.45. So that's because that's the fine adjustment. So negative zero point 0.4 and this is 0.04 together, that's nothing but negative. So for moment you can just take module or just forget that negative sign. 0 0.4 plus 0 0.05, that's nothing but 0 0.45, and then of course your z is negative 4.5. So you want to go all the way across the row till you hit the column corresponding to addition of fine adjustment of z as 0.045, because these two together will constitute to z score of 0.45. That's why you're going to look at that intersection point, and that's nothing but 0.3264. So that is going to be your area of interest, 0.3264. In other words, if they have asked us proportion, then you can say that 32.64. But in this particular question, they have asked us probability, so you can keep it like that, 0.3264, and then you can write your final answer as 0.3264 is the probability that randomly chosen late preterm baby would have low birth weight less than 2,500 grams. Now if you look at the B part, it's just the same thing, but now you just have different x value. Less than, again simple one, less than 1,500. So x in this case, you know this mu is mean 2750, sigma is 560. This is how you draw that. This is your x being 1500. That's the only difference, but you also know that you want to find area left to the curve, and then you're going to follow the rest of the steps similar to that we have did here and get that final answer. So I'm not going to repeat this procedure because I think it's just the same thing, but I'm going to give you the final answer right here. But you just make sure you solve that and get this value. So that area you will get it as 0.0128. So practice that and see if you get this answer for part B. Now I want to go over this question as well. Arsenic data. You have been said that it's normally distributed with mean being this, standard deviation for population, sigma is this. What is the range of arsenic blood concentration corresponding to the middle 90% healthy adults? So similar thing, draw the area, draw the density curve, write down the data. So I have already written normal distribution. Normal distribution mu is 3.2, sigma 1.5. If I have drawn this as normal distribution curve with mean being z, that's z. Actually, if it's x, then that's going to be the mean of population 3.2, and then I'm going to have some standard deviation. So I'm going to write it here, but I've already written, so I'm not going to write it again. But specifically what you want to do in highlighting this or drawing this diagram density curve is identify what is the area that they are asking. So if you read carefully, they are asking what is the range of arsenic blood concentration level, and you know this is the data for arsenic blood concentration, so they are asking it in terms of x value, right? But what x value? They are asking for range, so it's going to have some lower boundary and upper boundary. So lower and upper boundary for what? For the middle 90% of healthy adult. So let's say if this is the 100% data or entirely, and if this is the middle 90%, they are asking me particularly what are this lower boundary of x, that is x1, let's say, and what is this upper boundary of 90%, that's nothing but x2. That is what they are asking. So that will help us understanding the question, what are they asking, and then you're going to try to find this x value. To find this x value, since it's not within that 65, 95, 68, 95, 99.7 rule, you know that you have to transform this x values to z to find those particular x value. So to transform that z value, even before transforming that, we have to first find uh, what can we derive, what can we, what would be the z that we should look for to get these areas. So that is the another key piece of information that we can make use is about symmetry of curve, and then that's the first key. And second key that we are going to make use of is the total probability being equal 1, or the area under curve. Total area under curve is 100%, right? So if it's total area for under this curve, normal distribution 100, and if the middle part is 90, if we exclude that from the 100, we know that we will be left with 100%. That's this plus this shaded area together. But by symmetry, we know that since these are like lower 5%, upper 5% together constituting 10%, we know that this is symmetrical data. So we can simply take half of this 10%, remaining 10%, that will give us 5% on either side of this middle 90%. So by saying that, we are saying already that area on the left side, if it is middle 90%, on the left side of this is 5%, we are saying that that particular area is 0.05. So if we know the area, we can find z by making use of table B as well. But this will be from inside out. So let's go over how to find z given the area. Okay, so our area is 0.05. So we'll be looking for area. We know the area. For area, we have to look inside this particular square. So 0.05. So 0.05, you're going to look at 0.04, 0.049, 0.05. So this is 0.05, this is 0.049. So it should be somewhere in between here, right? So for coarse adjustment of z, you can simply know that grossly your z will be somewhere around negative 1.6. But to get that specific answer, we have to fine tune, add this fine adjustment, that's what I like to call, to that z-score, and you can see that that's also not the whole number, I mean not the precise number given here. So you're going to take the average of these two or sum of this, because it's the middle point, right? To get the middle point, you just divide this two number, add this two number and divide by 2. So if you do that, 0.04 plus 0.05 divided by 2, that's going to give you answer at 0.045, right? That will be this particular point. And you know that this is nothing but the addition of fine adjustment to this number, so that's how your z value for that particular area is going to be 1.6 plus this fine adjustment, that's 0.045, that's nothing but 1.645. Bear in mind that I have neglected this sign of negative for just the addition of fine tuning, because it's just the addition, it's just the fine adjustment of z-score, but your z value is going to be negative. So just add that negative sign later on in the final step. Probably you're going to solve it in one step, but I just wanted to go through this so that you will understand. So you know that now the z is negative 1.645. So now we are going to make use of symmetrical property to find this corresponding z value first before finding the x for the same, because you know that this area is going to be similar to this. I know it's not drawn exactly like that, but forgive my drawing for that. But you just understand these are the same area because these are the same 5% on either side. So that z-score is going to be exactly same in magnitude, but it's just going to be positive because it's on the right hand side of the mean z-score being 0, right? And we know that everything, all the z-score on right side of mean being 0 is going to positive number, everything on left is negative. So you can simply find that as positive 1.645. And you can also cross check that particular z-score 1.645, positive number 1.6, and then actually if you find that 1.645, that's going to be this number somewhere around here. That's going to be area left of z. So that's going to be area everything on this left side. But your area is area right of z, so you just subtract it from 1. But that's just the another way, although complicated, that you can also consider. Simple way, you know this is symmetrical curve, this area is going to be equal to this, so z is also going to be same in magnitude but different in sign. So once you know the z, you know the formula z is equal to x minus mu upon sigma. And let's say if you call this as x1, you know this x1, you don't know this x1 because you have to find this range of arsenic level corresponding to middles 90%. So basically you have to find this x1, but you do know z-score, that's negative 1.64, mean, that's you also know for x, mean is for x is 3.2, and sigma for x distribution is 1.5. So basically you know everything but the x, right? So you can just solve that by rearranging the equation. So x1 minus mu is going to be equal to z times sigma, and then x1 is going to be z times sigma plus mu. You know z is negative 1.645 times sigma is 1.5, and then you're just going to add mu in this case as 3.2. And if you solve that, I'm not going to solve this math because it's just a pure math after that. If you solve that, you should be able to get the value somewhere like 0.73, that is going to be your lower boundary. So ultimately you found this x1, right? Similar thing you can do it for x2 by making use of x2. Z, you can find that z2, that's your upper boundary. So by this formula, x2 minus mu is going to be z2 times sigma. This will be z1. I'm not going to write it again, but understand that z2 sigma plus mu is going to be x2. z2 is positive 1.645 times 1.5 standard deviation, and then you're going to add mu 3.2, and if you solve that, you should be able to get answer like something like 5.67. That's going to be x2. So now you say that the range of whatever that lead, or I don't know, arsenic, okay, arsenic blood concentration. So range of arsenic blood concentration representing middle 90% is 0.73 to 5.67, and you can actually calculate the difference as well, but even this should be fine. So that's how you can answer this kind of questions. Alright, so now going back to this question, I think this is pretty simple question. In this question you don't have to find the z-score because it's the x in this term, in this questions is nothing but simply you can interpret in terms of standard deviation. So let's go over that. Read that it's normal distribution, mean is given to you, standard deviation is given to you, this rule you know, and they are asking us x value, all, or actually not x value, they are asking us proportion or area. Almost all 99.7% horse pregnancies fall within what range? So by 99.7 in rule, we know that that's plus minus 3 standard deviation. And if you add for A part, that's plus minus standard deviation around the mean. So I should write mu as population mean. Mean in this case is 336. That's going to plus minus 3 times standard deviation. In this case, standard deviation is 3 days. So standard deviation is 3. So you're going to get two values. So if you do 336 minus 3, that's going to give you 332. Upper boundary will be 336 plus 3. Actually not 3, because 3 times 3, that's 9. 3 times 3 addition, that's 9. So if you subtract 9 from 336, that's going to be somewhere around 327. Yep, that is 327. And if you add 9, remember this 9 is because 3 times 3, 3 standard deviation, 1 standard deviation is 3. So 3 times standard deviation is 3 times 3, 9. That's why we are adding or subtracting 9. And that's going to give you 345. And you're going to say almost 99.7% of pregnancies fall within range of 327 and 345. So that is what your A part. Now B part is asking us what percentage of horse pregnancies are longer than so greater than 339. So if you draw the diagram with the mean, solve for that diagram, we just have to fairly draw it symmetrical. We know that mean is 336, standard deviation is 3 days, and we are looking for 339. So 339 would be somewhere here. And try to look if you can interpret this x value in terms of sigma, meaning that if you add one standard deviation to this 336, so one standard deviation is 3, so if you add 3 to this number, 336 plus 3, that's 339. So you know this number represents positive 1 standard deviation, greater than the mean. And they are asking us what is the percentage, what is the percent of horse pregnancies greater longer than 339. So our area of interest in this is this particular area. So how to find that area? You know that till one standard deviation, let me just draw it here. Within this one standard deviation around the mean, that's negative one standard deviation and positive one standard deviation, this entire area is 68%. So that means the area on one side around this mean, so if this is mean midpoint, area on this one side around till the positive one standard deviation, that's going to be half of this 68%. Why half? Because we know that these are all symmetrical distribution, because these are normal distributions. So half of that is going to be 34%. So we know that this is 34%, this white area or this shaded area. Okay, and we know that since this is the half symmetrical distribution, so area everything after that is going to be 50%. So we just subtract to get this black area shaded in black, that is the area of our interest. We just subtract 34% from 50%, and that's going to give you 60%, 16%. That's your final answer. So you're going to say 16% of horse pregnancies are going to be longer than 339 days. And then there are going to be multiple ways you find this area. You can do it either way. Add this 34% to 50%. That's going to give you something like 84%. And then subtract that from total area 1. That's going to give you 16% again. So there are like multiple ways, but whichever way works for you, just follow that.